Hey everyone, today we're going over random pick with weight, and on first read this question isn't super easy to understand, but let me break it down right now. The first line is just telling us, okay, we're going to initialize our solution object once, and then call pick index once. And if we actually look at what we need to fill out, it's not too complicated. All we're doing is filling in the initializer, and then what the pick index is going to do. So we see that W is actually the only thing that's being passed in here, which is going to be the list of weights here. So what does the input actually mean here? If we look at the first example, 1, 3, the total is 1 plus 3, which is 4. So the chance of picking the first element is going to be 1 over 4. The chance of picking the second element is going to be 3 over 4. Similarly, if we have 2, 2, 5 as the input, the total is 2 plus 2 plus 5, which is 9. So the chance of picking the first element is 2 over 9, second element is the same, 2 over 9, and then the third element is going to be 5 over 9. So that's all the input is telling us. So let's take this example 1, 3, and build some intuition around how to solve the problem. So I know that the total is 4. So if I were to generate a value that has 4 potential values, then I could probably map each of those 4 values to essentially a bucket, where this bucket is 3 times the size of this bucket. So what I mean by that is, okay, why don't we generate numbers from 0 to 3? And what we can do is, okay, if the number I randomly generate is 0, we'll tell it to pick the value at index 0. And if the number I generate is 1, 2, or 3, then I would take element at index 1. So how do we know this works? Because, well, like I said originally, the chance of picking this element should be 1 over 4, right? The chance of picking this element should be 3 over 4. And if we're generating a number that's either 0, 1, 2, or 3, if it's 0, well, that's one of the 4 numbers, right? So we can just tell it to pick this value. And if I generate 1, 2, or 3, that's 3 of the 4 values. And we can just pick this value. Let's look at the second example. If I were to generate a number from 0 to 8, how would this look? So if I picked 0 or 1, I'll map it to this first bucket. If I pick 2 or 3, I'll map it to the second bucket. And then if I pick 4, 5, 6, 7, or 8, I'll map it to this third bucket. So there are 2 numbers in this bucket out of the 9 possible values, 2 out of 9 here, and then there are 5 values, 5 over 9, which is exactly what we want here. So essentially what we're doing is generating a number from 0 to the total minus 1, and then we're going to map it to one of these buckets. So we generate a number from 0 to the total minus 1, and how do we map that number to a bucket? That's where the idea of this prefix sum comes in. And say we picked the number 6, how do we know which bucket it falls in? Well, it's between 4 and 9, so we're going to map it to bucket 3. And say we generate a number that's 3, well, that's between 2 and 4, so we're going to map it to this bucket. Now, how do we determine the bucket in less than linear time? That's where the idea of binary search comes in, because prefix sum arrays, where the numbers are all positive, it's guaranteed to be sorted, so we should take advantage of that property. Take a look at the code and generate the arrays that we need to solve the question. So we'll initialize an array to 0, and then for each weight, we'll append the weight plus the last element in the array. For example, 1, 3. We start with 0, then we append 1 plus 0, which is 1, then we append 3 plus 1, which is 4. For the second example, 2, 2, 5, we start with a 0, then we append a 2, then we append a 2 plus 2, which is 4. Then we append a 5 plus 4, which is a 9. So now let's take a look at the pick index code, which looks like your typical binary search. You have a left and right, and you have a mid. So let's walk through some examples using the 225 case here. If the number that we randomly generated was 2, well, that's pretty easy because that matches that value there, and we can just return mid, which is 1, right? However, if, say, we had picked 3, well, 3 is between 2 and 4, so it should still map to this bucket here. So if the pick is less than the value of the next bucket, then we can still return mid as well. However, say we had picked 6, well, that's greater than our next bucket, so we know that we need to check the buckets on the right. And say we had picked 1, well, 1 is greater than this previous bucket here, so we know that we can just map it to the previous bucket, so we'll return mid minus 1. But say there were more buckets on the left, then we have to check the buckets on the left, so we just make right equal to mid minus 1. So what's the time complexity of the solution? If we look at the initializer, we are just iterating through the list of weights once, so that's O of n, and then we need O of n additional space to construct our prefix sum array. For pick index, each of the calls are going to be O of log n time because we're using binary search. And let's go ahead and submit this code, and we can see that it's accepted. Let me know if you have any questions in the comment section below, and I'm also taking requests for any other solutions that you want to see. Thanks.